Hello, Algebra students. This is Chapter 2, Section 2, Solving Equations by using addition and subtraction, or you'll see here I like to call this lesson the golden rule of algebra. Whatever you do to one side of an equation, you must do to the other. The goal when solving equations is to isolate the variable. Whatever we're looking for, the unknown, we're going to isolate the variable, get it by itself. To solve an equation means to find all values of the variable that make the equation true. We're going to use inverse operations when solving for the variable. Inverse operations, we talked about that in Chapter 1. The inverse of addition is subtraction. When you have a positive 5 and you add to it a negative 5, it gives you 0. That's the inverse property. The inverse of subtraction then is addition. So that should have been subtraction, addition. All right. If I were to ask you the inverse of multiplication, I hope that you would say that inverse is division. And if I asked you about division, of course, the inverse would be multiplication. That's coming up, so stay tuned. All right, so here's an equation, and we're asked to solve each equation. But then it also asks us to check our solution. To solve this equation, I want to isolate C. So I need to undo what's happening to C. The inverse of adding 102 would be to subtract 102. Well, whatever I do to one side of an equation, I have to do to the other. Otherwise, our equal equation, where everything was balanced, like a teeter-totter here, if I change and I subtract 2, all of a sudden that side becomes off balance when you subtracted 102, and this side would then be heavier. So to keep them equal, we have to do the same thing to both sides of the equation. If you want to draw the teeter-totter and leave it there, you may. Alright, so let's go back to my pen, find my fun blue color. Alright, so those will cancel and I'm left with C equals, now 36 minus 102 is going to give me a negative because they're integers. Opposite signs mean subtract, and we're going to keep the sign of the larger number. So it's going to be a difference of 66, and it's going to be a negative 66 because 102 is the larger absolute value. I think this is the answer. Now let's check. So I'll pick a new color to check. Negative 66, I'm going to replace C with negative 66 plus 102. Does that leave me with a positive 36? And it does, so it does check out. Alright, I'm going to draw a line because I'm crowding my second example and change colors. So let's look over here. We have 4 plus 4/5. So if we're adding 4/5, we're going to need to subtract 4/5. And we'll do that to both sides. I'm going to write over here negative 4/5 or subtract 4/5 to the side. Those cancel, so now I have y equals. Now how do I subtract 2/3 minus 4/5? Well, I need a common denominator. The common denominator here is going to be 15. 3 goes into 15, 5, and 5 times 2 is 10. Minus 5 goes into 15, 3. 3 times 4 is 12. So 10 and 12, opposite signs, it's 10 minus 12. So I subtract, keep the sign because 12/15 is larger than 10/15. And it's negative 2/15. I think. Let's check our answer. So I'm running out of room. Let's check it over here in this little area. Let's find the color purple. And I'm going to say negative 2/15 plus 4/5. Does that equal 2/3? Common denominator would be 15. So I don't have to do anything to the first one to get a 15 here. 5 goes 3, 3 to 4 is 12. Whoops. Does that equal 2/3? I'm checking. It's going to give me 10/15. Does 10/15 simplify down to 2/3? It does, so I'm going to say check. All right, so for this problem, I'll add 4 to both sides. So t equals a -3. Let's check. -3 minus 4, does that equal a -7? Same sign, both negative, so we just add and keep it negative. -7 equals -7, it checks out. So t equals -3. So some are easy, some are a little more complicated. Alright, now we're going to take this word problem. Write an equation and solve and check. 14 more than, let's change colors. 14 more than, so 14 is going to be last. More than what? A number. So some number, I don't know what the number is, so I'm going to use x. 14 more than a number is equal to, that's what we were warming up to in our earlier lesson to find out that that means we're going to have an equation, is equal to 27. Find the number. So we'll subtract 14 from both sides, and x equals, when we say 27 minus 14, we're left with 13. Be careful, we're not finished. It said and check. So now I'm going to say 13 plus 14. Does that equal 27? 27 equals 27. It checks out. All right, the day after a hurricane, the barometric pressure in a coastal town has risen to 29.7 inches of mercury. Oh, it's risen from where? Well, this is 2.9 inches of mercury higher than, oh, there's that word, that dangerous word that we have to pay attention to, that than word. This is higher than the pressure when the eye of the hurricane passed over. So our new pressure is 29.7, and that is 2.9 higher than our normal pressure. So let's pick a variable, let's define it. I'm going to use P for our normal barometric pressure. I'm not sure if I spelled barometric right. Please don't hold it against me. P. So our normal pressure rose 2.9, and now our pressure is 29.7. So I haven't even finished reading the question yet. Write an equation that represents this situation. Okay, I did that. What was the barometric pressure when the eye passed over? So I'm solving for that normal pressure. So I need to subtract 2.9. Keep those decimals lined up. And P is going to equal 9 from 17 will be 8 to borrow, so 2 from 8 is 6, 26.8. And it did not tell me I had to check this time, so for the sake of time I'm not going to check. But I see here it's several problems. It says try these on your own. Try these 6 through 8, but the next page, wait, and we'll do these in class together tomorrow. So stop at 9. You can stop here, and we will start up there tomorrow. So go ahead and try 6, 7, and 8 on your own, and I do want you to check, solve and check for the rest of our lesson for tonight. All right, thank you, and I hope that you all have a jazz-filled kind of day. So my music is jazz music today, so I hope you're having a jazzy day. Jazz it up. All right, see ya.